Um, Today, what we're going to get into a little bit, if you're somebody who really likes the book, it's 8.4. But what it is, what we're going to start talking about is graphing in what's called vertex. Okay, we're going to start graphing in vertex form. So for a minute, I want you to we're just going to look at, you guys were used to, we had the equation ax squared plus bx plus c. I should say y equals. And that was our standard form from last week, and even on Monday we started talking about that. All right, that was our standard form. Today, what we're going to start talking about, we're going to look at a little different form, okay? And it's just going to be what's called vertex form. And so it's going to look something like this. And we'll kind of look at it in pieces, okay? Our vertex form is going to be in this form, okay? Where your vertex is HK. Okay, and before you get, so A is just that coefficient out in front, and then we'll start looking at, this is a really easy way for us to find the vertex, okay? So first example I wanna look at a little bit is what would happen, all right, we're gonna compare two equations. We're gonna say y equals x squared versus y equals x minus 2 inside parentheses squared, okay? So if we think about a graph of this function, get my axes in here, we would have the function, actually I'm gonna make it a little bit lower for us. What would can you guys just start plugging in some values or shouting out some values if we were to do this? I'll put our x-axis down here and our y-axis up here. If we plugged in 0 for our first one, we'll do this one in red and we'll do our other one in blue here. For y equals x squared, what we have? We'd have 0, 0. If I plug in 1, I'd get out 1, right? If I plug in 2, what would I get out?
2.
Yeah, so I plug 2 into my equation here. 2 squared.
Oh, 4.
Yeah, we get out 4. Okay. And it turns out if you plugged in -1, you'd get -1 squared would also be. So our graph would look something like this. If you want to do it with your input-output tables, you could do that. All right. So that would be our, this is just, our red graph is y equals x squared. Now for a minute, let me move this over, okay? Let's say we're gonna look at our xy tables for x minus 2 squared, our blue equation here, okay? So let's just start with 0, 1, 2, 3, and 4. We'll just look at those values and see what we get. What happens if we plug 0 in? We'd have 0 minus 2 squared. What would we get out? 0 minus 2.
Positive.
Go ahead.
Wouldn't it be positive 4?
It would be positive 4 because you'd have 0 minus 2 or -2, and then you square it, you get out positive 4. So we know if we plug in 0 for x, our output must be 4. Okay. What would happen if we plug in a 1? 1 minus 2 squared.
1.
Yeah, we get out 1. So we'd actually still be at that point right there. And if we plug in 2 minus 2 squared, we get out 0. Okay. And then if we did 3 minus 2 squared, well, 3 minus 2 is 1. You square the 1 and you get out 1. And can you guys see what's happening here?
Yeah. Mm-hmm.
What's happening to our graph?
It's flipping over.
Yeah.
What's the word? Oh.
Oh, there is a word. I didn't even think of it. All right, we know the word. Good. Or we're thinking of it.
Oh, wait, it's like shrink and...
Okay. We'll talk about that in a minute. We will talk about that in a minute. If we had a number out in front, that would be a vertical shrink or stretch. But in this case, we just have a 1 out in front. So there's no shrink or stretch, but we will get there, yes. What happened to all our points? When I go from the red to the blue?
Oh, it slid over.
Yeah, everything got shifted to the right 2. Okay, everything got moved to the right 2. And notice our equation, we had x minus 2, okay? And our vertex in this case, or our lowest point, well, if we were to put this, it would be 2, 0, okay? That's where that x minus h comes from. Well, your vertex, x minus 2, if h is 2, well, your vertex better be 2. And then we don't have any number on the end yet, so that's where the 0 came in, okay? Let's look at one more just like that. Let's look at one more, okay? This time, let's say, and I'll let you guys start to make the input-output table on your own. Let's say this time our equation is going to be x plus 4 squared. Y equals x plus 4 squared. X. And tell you what, I'm going to give you the x values. Let's do -6, -5, -4, negative, and then whatever you want, -2. Actually, we'll do -3 and -2. All right.
Mr. Jones.
So when we do these problems on our own, should we use those numbers like 0, 1, 2, 3, 4, or like?
Great question. And then Treasure, I know you had a question, so I want to get to that too. My suggestion would be, so I use 0, 1, 2, 3, and 4 because I knew that the vertex was going to be 2, 0, and I wanted you to be able to see how it moved over. In this case, you guys see how it was x minus 2 and it moved to the right 2? When this is x plus 4, what would you predict is going to happen?
It's gonna go over 4?
Which way over 4?
To the left.
Yeah, okay. When there's a plus something, it's going to
Backward.
move to the left that many units. So what we're going to find out
Oh,
is,
so it's opposite. Okay.
yes, it's the opposite sign. Or I tell people, if you want to think about what number is going to make this inside piece, inside parentheses, equal to 0, you could think about it that way. So yes, if you start to plug these in, you're going to get, let me get my pen back. You're going to get our same 4 points right here. All right, our same 4 outputs, because I centered this around -4. So if we go to graph this for a minute, if we go 6 to the left, 1, 2, 3, 4, 5, 6, we have to go up 4, be right there. And so our graph would look something like this. Okay. And right there. Nope, not doing it. Okay. So if you did it with 0, 1, 2, 3, and 4, all that would happen is that you would get some points way up here. All right, you get the points way up here. And so what I want you to understand is if it is x plus, I'm just going to put an h. H is just whatever number. Your graph is going to move to the left, or your vertex, everything's going to move to the left, h units. Okay. In our first example, we had x minus 2, or in this case, we're just going to say h, whatever that number is. And all that's going to happen to your graph is it's going to move right h units. So it is kind of backwards, like Bella was saying. Okay, right h units. And so that just depends on what the sign, all right, what is the sign on the inside of your quadratic there, inside your parentheses. Questions on that? No. Okay. Let's kick it up one notch. Okay. This is the main idea. If you can get this piece right here, this is really important. Right? This right here. This tends to be what trips people up. Okay. So go ahead and if you're writing stuff down, if you're writing stuff in a notebook, I would jot that down. the other piece, and I'll leave that up there. The other piece, we're gonna get a little bit more tricky, and we're gonna say, what happens if we have an equation that looks like this? Y equals x minus 3 squared, and then we're gonna put a plus 1 on the end. Okay. And so actually, do you guys, let's do, just for this one, we'll do the input output tables, and for our next example, we won't have to. How's that? We'll do our x, y, and I'm gonna tell you guys the x values. Let's do this. Let's go 0, 1, 3, 4, and let me move this down a tiny bit, and 6.
Wait, so what's the deal with the X values? Do they matter?
That's exactly what I asked.
Okay. Oh, I'm sorry, I didn't get you. So we're just, I mean, you could do this for any points. Based on what we said up here, let me write. Based on what we said up here, what would you guys predict would happen from this? Just this inside piece.
It's going to go over 3 units.
Yeah, which way over?
To the right.
Okay. So this is where we got to kind of look at. If it is x minus h, so in this case it's x minus 3, we can look and it'll say, oh, okay, hey, it's going to move. Oops, my pen's disappearing. It's going to move to the right h units. So this is actually going to move to the right 3. Our vertex is going to move to the right 3. And then we have to figure out, what is this plus 1 going to do?
Is that going to be like your y-intercept or? No. Oh, no, it's going to bring it up 1 unit.
All right. Okay. So you do remember something a little bit from, we talked about this right before you guys left for spring break. Let me pull this up for 1 second so you guys can see it. I'm going to stop my share and share my screen with you guys so you guys can see what the graph looks like. Okay. Can you guys see the Desmos?
Mm-hmm.
Yeah.
Squared, and then we have a plus 1. Okay. Do you see where our vertex is?
Mm-hmm.
If we compare this to our original graph, y equals x squared, our vertex moved to the right 3, like we said, and then up 1. Now, if we change this to, let's say, a minus 2, it's still going to move this piece right here is going to move us to the right 3, but then this minus 2 is going to move our entire graph down 2 units. Okay, down 2 units. And so, Treasure Neil, your question about, hey, what x values should I use? Okay, I'm knowing that the graph is going to move to the right 3. I was picking x values around x equals 3. So I picked 0, 1, 3, 4, 6. I didn't tell you, hey, pick -4, because if you zoom out, if I plugged in -4, it'd be way up here. Okay, that's why I was kind of picking the x values I was. Does that make sense or no?
Yeah.
Yeah.
Okay. And so you guys might not have known that, but that's why I was picking the x values I was picking. So yeah, just knowing that, hey, the -3 is going to move it to the right 3. If we had said, let's make this +3, you see how the graph moves. Now it's moved to the left 3, and it's still this -2 on the end moves it down 2. Okay. Let's do this. You guys tell me what would happen if we said, before we type it in, what if I said the quantity x plus 4, all right, x plus 4 squared, and then I say a -1. How is that? So x plus 4 quantity squared, and then I have a -1 in the end. Think for a second, how is that going to move the graph?
Left 4, down 1.
4. Okay, and then we have a -1. All right, again, that +4, Neil's right. That +4 is going to move it to the left 4, and this -1 moved it down 1. Okay, So you can just start, and if you guys want to use Desmos on your homework, by all means, I will actually send you guys, I found a decent calculator app where you can graph on your phone or iPad or Apple device. So I will send you guys that. I do want to, Bella, you talked a little bit about the vertical stretch or shrink. What do we, and this, I'll kind of open this up, anybody, what do you guys remember about the vertical stretch or shrink?
There has to be like a negative or something that, like, there has to be like a number in front.
Okay. Yeah, it's going to have
something.
something to do with this number in front that, all right here where my cursor is. So if we make this, let's just say it's a -1 for an instance. You see what happens?
Oh, it's going to
we still
reflect
move
it?
over left 4 and down 1, but as soon as we put a negative out in front, our graph flips upside down. Okay, that's all that happens. All right, as soon as you have that negative out in front. So if we go back to positive, it flips right back, right side up. What happened if I put a 2 in front? You guys want to make a prediction what's going to happen?
Is it, shoot, does it like make it wider or like shrink it or something?
It does something. Let's take a look. Oh, click that. If we put a 2, you can't really. I'm gonna make it a bigger number. I'm gonna make it a 5, just so you guys can see what happens. You see what happens?
Oh, it
The graph
shrinks
is,
or
well,
stretches it.
yeah, it takes everything and makes it really skinny. And so the analogy I always use, all right, I want you guys to imagine, if I don't have a balloon here. All right, balloon has a certain amount of air. If you make everything really skinny, you're also vertically stretching it, right? So that if that number is bigger than 1, you're vertically stretching it and making the graph really skinny. Now let's go back and look what happens if we make this, let's say we make it 0.2. What happened to the graph?
Oh, it shrinks it?
Yeah, it vertically shrink it. It made it flatter. So that part we'll get to a little bit on Friday. I'm just giving you a preview of what's to come. So let's do this. We'll do one more example, and then again, 30 minutes. If you're getting 30 minutes of math every day, that's a win in my book. So let's shoot for this. Go ahead, and I want you guys to go ahead and graph this equation. Let's try. All right, x plus 3 and then a -2. So the quantity x plus 3 squared. I'll go back to my iPad in a second. X plus 3 squared -2. So just think about, where is the vertex going to be on that graph? Go back to my iPad. I'll put the equation up in just a second for you guys. X plus new page. Y equals x plus 3 squared -2. Okay. And tell you what, you guys seem to like, my Algebra 2 class doesn't seem to like drawing on there. But we'll make our graph something like this. All right, if you guys want to go ahead and draw in on there, I think you can use the annotate tool. So if you got an idea, hey, here's where the vertex is going to be, things like that, go ahead. Or if, hey, I just know where this point is, so maybe you're making your XY table over here. I'll give you a hint. If you're looking for X values, I would use -5, -4, -3, -2, and -1. Yeah, if you have 1 point, go ahead and throw it in on the on our document here. Maybe somebody else will have a different point than you. Do you guys know how to annotate? Some of you?
Yeah.
If you go on that little bar at the bottom where it says new share, participants, etc., I think you should have an annotate tool. If you're on a Chromebook, maybe not. I know my dad's look different because he's got a Chromebook for his school. Or if you just want to shout out a point, I can put it in.
-5, -4.
All right, you put in -5 plus 3.
Oh, wait. No. That's 2.
Yeah, -5. So -5, I'll do a little up here. -5 plus 3 squared would be -2 squared, but then you still have this -2 on the end. So
that'd be 4.
This would be 4 minus 2, or 2.
Yeah.
So -5, 1, 2, 3, 4, 5. I can't count. Up 2. All right, so we got that point. What other point do we have?
-1.
What's that?
-4, -1.
All right, so we got that point here. Good. Any other points? Let me ask you this. What's going to happen to our graph based on, I might change colors here too. Based on this and based on this, what's happening to our graph? What is the +3 on the inside going to do?
It's going to bring it over back 3 units.
Yeah, it's going to move it left 3. And this -2 is going to move it down 2. So we talked about our original quadratic, the vertex was at the origin. Well, if we move our vertex left 3 and down 2, it's going to be right here. This is going to be your vertex, okay? That's the nice thing about vertex form is from this, you can figure out the vertex right away. Yeah, you don't have to do the, okay, I see somebody annotating on there. You don't have to do any of the, -b/2a like we did last week. You can literally say, all right, what is h and what is k? K is literally your number on the end. And then remember we said x, I'll put it down here, x minus h squared plus k. Well, if we look at our example here, x plus 3, we could really say this is x minus -3, right? That's the same thing as +3. And then we have a minus plus -2. I'm just rewriting this equation down here, okay? Well, in that case, h is -3, so our vertex better be -3, and k is -2. So we just found our vertex, okay? This right here is going to be your vertex, x minus h squared plus k. The only thing you really had to remember is that it's going to kind of be the opposite, as Bella said. So if it's -3, it's going to move it to the right 3. But in this case, since we had a +3, it's going to move it to the left 3. That's how you can always find the vertex, okay? I guess if you were really interested in finding the y-intercept, you could have plugged in 0 for x. I think you would have gotten out 7 or something along those lines. So you would have found your vertex or your y-intercept up there. But again, in this form, we're really concerned about finding your vertex. And your vertex is just going to be h comma k. Okay. Questions? Okay, Lauren had a question. What if there's a variable attached to the x like 3x? So Lauren, your question is, what if we have something like this? Yes. Great question. Basically, we are not going to look at that in here. What this 3 would do is it would be a horizontal stretch or shrink based on if it's bigger or smaller than 1. We're actually not even going to look at that. This is as in-depth as we're going to go. So great question. The 3 is going to be your horizontal stretch or shrink to answer that. It's on tonight's homework. Which one did I give you guys? Oh, wait, that's my Algebra 2 book. 19. Let me go back to my Big Ideas book. Oh, dang it. I'm in Annotate. 19. I'm looking at it right now. I can stop my share. Give me 1 second while my computer loads. So 19. Well, 19, it's the 3 is on the outside. So we can, if you guys want to, we can look at 19 right now. I'm going to add a page after page 4. Okay, so here's the big difference. Let me share my screen one more time. Here's the big difference. Yeah, I was like, I can't believe I did that to you guys. If it is 3 and then I think it's x plus 1 squared, this 3, since it's on the outside, is going to be a vertical, and since in this case it's bigger than 1, it's going to be a vertical stretch. Okay. If it were on the inside, and this is kind of a little bit of extra stuff that a lot of times we don't get to, if this 3 is on the inside, this is actually a horizontal shrink. Okay. Think about a horizontal shrink. Think about, let's go back to our balloon analogy for a second, right? If we stretch a balloon vertically, a vertical stretch, we are also, that air has to go somewhere, so we're kind of shrinking it horizontally, right? Horizontal is the x-axis, kind of things that move horizontally on the horizon. You're looking out on the horizon, it's flat. So we're horizontally shrinking. A horizontal shrink is the same thing as a vertical stretch, okay? And so that's why that if the 3 is on the outside, we call it a vertical stretch. If the 3 is on the inside, we call it a horizontal shrink, okay? Does that help with that question? Okay, good. Other questions from you guys? I think our big takeaway is this, okay? This will be the last thing I leave you guys with. Right? We said our general form is going to be a, and then we looked at x minus h squared plus k. All right? This number on the end is going to tell you, hey, does the graph move up or down? Okay? This number on the inside, if it's subtraction, you're going to move to the right. If you're adding something, if there's addition going on, you're going to move to the left. Okay? That's the big takeaways. This number out in front, let's not worry about this. We'll talk about it on Friday. This is your vertical stretch or shrink. All right? That's your vertical aspect. Okay? That's about it. That's the big idea. Questions from you guys on anything? Okay. Well, hey, if you're struggling, I have office hours tomorrow at 10, so feel free to stop in. Hopefully you can get out of bed by then. I encourage you to stop in there if you're struggling, or again, I just showed you desmos.com, DESMOS.com. That's a great way to be able to graph and see what the graph's going to look like, and it'll even give you the vertex. Okay. Friday, we're going to continue to visit this idea in a little bit more depth. We'll look at some vertical stretch and shrink, but the main idea is going to stay the same. And then next week we'll, look at a little bit of intercept form and remind ourselves how to factor. And then we'll take tests next Friday. And it'll just be 3 questions. It's going to be on Flipgrid. So I encourage you to do this week's homework quiz because that would be good practice and I can give you some feedback on that. And it's pretty low risk. It's not worth very many points at all compared to the test. So that way you'll have hey, I know how to do this. The test should go pretty well.
Wait, when is the homework quiz?
Homework quiz is just due by Sunday.
Oh.
I'm making everything due by Sunday. So if you want to do it today, you could do it today. If you want to wait till after Friday and make sure you got a pretty good handle on it, you could do it on Friday or Saturday or whatever. Just Sunday by 11:59. It's Monday. What'll happen is Monday morning, I'll get up and I'll put all the grades in. Some of you have already been submitting stuff and I've been slowly putting in grades in the computer. This class, I think I'm a little bit more behind. My Algebra 2, I got caught up. So if you've given me something and it's in that Google Drive, I shared that Google Drive folder with you, I will put that in. Okay. Well, is there anything else for the good of the class? All right. Well, hey, thank you guys. I appreciate it. And again, if you have questions, I'll see you tomorrow in office hours.
Okay.
All right. Bye, guys.
Bye.